This is a lab write-up for titration of vinegar. And at this point, you've already done a titration. So you're going to take your standard solution of sodium hydroxide that you've made and use it to determine the percent by mass of acetic acid, which is the acid in white vinegar and all vinegar that you just buy at the grocery store. So get out your lab notebook, open to a fresh page. You're going to call this titration of vinegar. Go ahead and write down your purpose. We're going to make some notes in our background. So vinegar is just a solution of acetic acid in water. And a very small percent of the mass of vinegar is actually acetic acid. Mostly it's water, but we can neutralize the acetic acid in vinegar with a base such as sodium hydroxide by titrating it. You would not want your vinegar to have any more acid than it already does. So a lot of people already have a hard time with the smell of vinegar. If it was more acidic, it would be even more sour. So we're going to draw our chemical reaction. There's our weak acid. Not very much of this acid dissociates. Then we have a strong base, that's sodium hydroxide. And this is a neutralization reaction. So you're going to make water, which I always write as HOH because it's half acid and half base. Then you're going to get sodium acetate. And our reaction's already balanced, which is really nice. We're also going to use phenolphthalein as our indicator again, so you have some experience with that. And it turns pink when it's basic. This is very similar to the previous titration you did, so I'm not going to spend a ton of time going over technique, but if you need to go back and watch the previous video on standardizing sodium hydroxide, you can go ahead and do that. Okay, so again, we're going to draw a procedure. You're going to rinse your burette 3 times with DI water. Make sure you get the whole burette rinsed, open the valve, get all the parts rinsed off nicely. Then it says use about 10 milliliters of sodium hydroxide. You can use like 5 to 10 to just coat the inside of your burette and the tip of your burette. Remember, you have a limited amount of sodium hydroxide solution, so you don't want to do a ton of that. Rinsing is only a small amount. You don't need a lot. Then you're going to fill your burette all the way to between like the 0 and the 1 mark. You never want to start at 0 because you don't have enough significant figures to make your calculations make any sense. So fill to maybe between the 0 and the 1, or maybe the 1 to 2 milliliter mark, and you need to record your initial volume. And then if you need to use a waste speaker to get the bubbles out of your pipette and do all that stuff to make sure it's full, you can do that. So write in here, no bubbles, because that will change your volume. You're going to rinse out a 250 milliliter Erlenmeyer 3 times. So last time we used a powdered acid and we dissolved it in water. This time you're just going to use vinegar that is straight from the grocery store. And we're going to figure out how much to use. Now your lab procedure says 6 milliliters of vinegar, but in the past I've noticed that if we use 4 milliliters of vinegar, this tends to work a little bit better. So in your procedure on number 4, it says 6 milliliters. Scratch that out and put 4 milliliters. So you're going to use a glass pipette to pipette this out. And it's going to live at one of the lab stations. And it holds 10 milliliters total. So just say holds 10. You need to pipette out 4 milliliters total. And then record the actual amount of vinegar you use. So if you got 3.8 instead of 4, go ahead and write that down. You're going to add that to your flask. This is your vinegar. Then you're going to dilute that vinegar, or just add another 100 milliliters-ish of deionized water. Then you're going to put your indicator in, and because it's acetic acid, it should be clear at this pH. All right, you're going to make sure that you've got your initial reading on your burette all done. You're going to titrate until you get that pale pink color, and then you'll record your endpoint. So you'll record your end volume. You're going to repeat this maybe 2 or 3 times as needed to make sure you get enough. If you are all done with all of your titration labs, all of your trials for standardization, all of your trials for titration of vinegar, you may rinse out your brown bottle, tear the label off, and hang them up in the room, and then we'll figure out a place to put those away. So when you're all done, but only if you're positive that you don't need any more trials, rinse all your glassware very thoroughly. You're going to hang your burette upside down. Okay. Again, I went through that really quickly. If you need to go back and review how to titrate, look at the previous standardization of sodium hydroxide lab, and that will show you how to do this in more detail. I'm also going to include how to use a glass pipette in here. All right. So, time to draw your data table. You should have 3 columns for each of the trials. So this is going to look very similar to your previous data table that you drew for standardization of sodium hydroxide. So instead of mass of KHP, you're going to use volume of vinegar. And I don't have a ruler, but you need to use one at school, or a straight edge. Okay, so we'll say volume of vinegar. Your molarity of your sodium hydroxide solution you don't really need to include, because hopefully it's the same for all your trials. Well, let's go ahead and put it in anyway, just in case you end up using more than one solution. Your starting volume needs to be in milliliters or liters, but you need to indicate which it is. Your ending volume, and then you need to figure out your total volume. Draw a nice pretty data table. Use a ruler. Label all your stuff. Trial 2, maybe trial 3, trial 4, I don't know how many it's going to take for you to get a good titration. Okay, so then skip a section, or skip a line rather. make a section called Calculations. And your first one's easy. You're just going to write your reaction. So I've already done that for you. For each trial, I don't care how you organize this, but you have to label all of your parts. So determine the mass that was in each sample. So let's just say trial 1, mass of acetic acid. So you're going to use your volume of sodium hydroxide. This is your total volume. You're going to use your molarity, whatever that was. Well, let's do this. So this is what was from your previous lab. It's a 1-to-1 mole ratio. And then your grams, that's going to be your molar mass of acetic acid. So you can determine that on your own. You do not need my help at this point to do that. Okay. Then for the same trial, you're going to calculate the mass of just the vinegar. We're not going to weigh it. We're going to use vinegar's density. So vinegar is really close to water. So water's density is 1. Vinegar's density is 1.01. Oh, a big difference. Gram per milliliter. You use 4 milliliters in the lab. So this is a pretty easy calculation. I'll just do it with you. You're going to get 4.04 grams. Then you need to determine your percent by mass of acetic acid in vinegar. And your calculations for how to do that are right on your lab page. So I'm going to let you do that on your own. Then you're going to do your average of all your trials and then state your conclusion and any significant sources of error that you may have encountered in the lab. You're going to turn in all 3 parts of this lab together. So making a standard solution of sodium hydroxide, standardizing the sodium hydroxide, and then this lab with the vinegar, using this to using your sodium hydroxide to titrate your acetic acid and vinegar. So that's going to be all one assignment. This is your rubric for the lab, so you need to make sure you have all of these parts, including your title, and that you've written your data tables with a ruler, and all of your parts are all together. And then we'll print off this rubric, staple it to the front of all your labs, and hand them in.